Okay, so we're going to talk about we're going to take all these skills that we've been learning about finding the zeros and factoring quadratics and all that stuff, and actually turn it into something useful in real life. And we're going to use an equation that is called the vertical motion model. And that equation is h equals negative 16t squared plus vt plus s.
Oh my
And I have to, and it looks scary, right? It looks pretty weird and scary and overwhelming a little bit. But once you understand it, you're going to realize, oh my God, really not hard at all. Because you're going to know what each one of these things stands for. And it's going to be very useful so that you can apply it in no problems. I wrote this down underneath it so you can see it's just a quadratic equation. It's y equals ax squared plus bx plus c. It's just that we're using different letters and numbers, right? We're using the a is the negative 16, the b would be the v, and the c is the s, the y is the h. We're using different letters so that we know what they stand for. They remind us what they stand for. Does that make sense? All right, so first of all, h. Let's figure out what it is, what these things stand for. H is the height of an object at any given time. So can we stop eating, guys? At any given time. Okay? So think about it. I kick a ball right here, soccer ball. Right? Yes? And the height, this is my height, right? This is my height, h. H-E-I-G-H-T, right? That's my height. At any given time, at this, and this is my time. Okay? So at 1 second, the height might be here. At 2 seconds, the height might be here. In 3 seconds, the height's there, and so forth. You follow me? It's the height of the line at any given time. All right, t is the time. The time in seconds. Okay? And the height, by the way, is in feet. The way with this particular formula. Right? So it's feet per second that we're talking about. What else do we have? V. V is called the initial vertical velocity. Okay? So what's velocity?
How fast something goes?
Yeah, it's how fast something's going, right? And think about it. If I took something like this marker, and I just dropped it, at the starting point when I dropped it, there was no initial vertical velocity, 0. Okay? It merely started to fall from that place. If it had vertical velocity, it would mean that it was being thrown upward first. Does that make sense? The vertical velocity is actually going up before. So like when you're diving, and if you're throwing something down, it would be a negative vertical velocity. But if you're throwing something up or jumping off a diving board, right, and making this beautiful arc, right, there is an initial vertical velocity upwards. Does that make sense? So V, and that's the one thing that's a little tricky, but that's given to you usually in the problem. So, but in this particular case, in these particular problems, there is no moving upwards. That's going to be maybe tomorrow or something, right? So there won't be any vertical velocity. So all the things are going to be like a boulder on a cliff that just suddenly breaks off the cliff or rolls off the cliff. Boom. No, it's not jumping up in the air first. It's just falling down. Okay? All right. What did I do with my marker? I dropped it. I guess. What else is there? S. Right? We got H, T, V, and S. S is so easy. It's just the starting height. The starting height. So if I kicked a soccer ball from the ground, what's the starting height?
0.
0. If I was on a cliff up here or on a diving platform and I fell off the platform, what's this? And it's at 68 feet. What's the starting height? 68 feet. So immediately, as long as I know, the T and the H will be unknowns, right? But then the V, the A will be negative 16. The V will be given to you, meaning it's the vertical velocity jumping upward. And the S will be given to you, right? If I shot an arrow in the air starting at 4 feet, if the arrow was 4 feet above the ground, that's your S. So immediately you know where to put this stuff. Does that make sense? That's your starting height, right? Okay, so now we'll actually do a real problem. Can I erase this stuff?
Yep. Yeah.
And you're going to see how easy this is. It's amazingly easy. So, okay, first one. So go ahead and write this down as I write it. Okay, a boulder that is on, this is number 1 on the homework too. That's not as on. That is 1,600 feet high. Where am I? Oh yeah, suddenly falls off the edge. Okay, falls off the edge. How long will it take to hit the ground? Okay. Now, ironically, okay, first of all, let's create our equation, right? We know what everything is, everything stands for, so we now just have to put it in the right spot, right? So it says a boulder that is 1,600 feet high. What is that? Is that?
That's H height.
Is that my H or is that my S?
S.
It's my S. It's starting at 600, right? That's my starting height, right? So that's my starting height. So I know that's going to be 1,600. So I know that's going to be 1,600. And then it says suddenly falls off the edge. Is there any vertical velocity going upwards when the boulder is falling? Just stop. I mean,
Unless
it just.
there's a little lip that is.
Fortunately, there is no lip on this particular edge.
Okay.
But that's a great question. If there was, then there might be a little bit of vertical velocity, right? Right? So we know we don't have that. So look, we have h is equal to negative 16 t squared plus 1,600. We just don't have our vt because v is 0, right? Does that make sense? Does that make sense, you guys?
Would have VT is like someone's like shooting a gun in the air or something.
Yeah. Yeah, totally. There would be a lot of initial vertical velocity from a gun. Like huge. It would be a big number, right? And we're going to, so all of these have no vertical velocity on this homework, right? Tomorrow we'll deal with vertical velocity, so you'll see. Because you solve them slightly differently, but you actually know how to solve them already. So this is what we have. And then it says, how long, this is the question, how long will it take to hit the ground? What is it? So remember, oh wait a minute, sorry, hang on a second. Well, here, we're up, this is 1,600 feet, right? And here's our thing, boom, and we're asked, how long will it hit the ground? Remember, h is the height at any given time. And what is the height right here? 0. They're asking us to find the zeros. Does that make sense? They're asking us to find it when the height of the boulder is 0, when it's on the ground. So they're asking us to do this. 0 equals negative 16 t squared plus 1,600. This is a piece of cake. You guys know how to do this. What would I do?
Oh, well.
Move this over. right?
Yeah.
So that it's a positive 16t squared, right? Wouldn't that be nice? Add those both together. I'll show it. Add 16t, add 16t, t squared. So that gives me 16t squared is equal to 1600. Now what do I do?
Divide.
Divide by 16, right?
Yes.
Divide by 16.
10?
So t squared is equal to 100. Now what would I do?
Then you find the square root of 100, which is 10.
Right, square root both sides. So I have t is equal to plus or minus 10. You with me?
Mm-hmm.
Look how easy that was, right? Totally easy. Now, what is the real answer, though? Say it again, please. 10 seconds. Could it be, can it be negative 10 seconds? No, can't be negative 10 seconds because it's after the clock starts, right? You know, it's going to be a positive number. So then I would answer the question, how long will it take? It will takes 10 seconds. And that's my answer. Does that make sense? Pretty easy. Now, one thing that's very interesting is when you look at a graph like this. I'm going to just do this a little neater. Is this on here? When you look at this graph, this is 1,600 feet, right? Up here. And you would think if the boulder just is dropping, wouldn't you think that the graph would just be a straight line down to 0? Wouldn't you think that?
No, it would.
But what are we leaving out when we do that? We're leaving out that there is a time. There's a time factor, right? As soon as the boulder starts to fall, then the clock starts ticking. And that's what happens. You know, that's what you're seeing. You know, the clock starts ticking, right? So you're actually seeing a parabola. Does that make sense? Because of the time. Even though the boulder, yes, is going straight down, when we graph it like this, based in time, we've got 2 dimensions. And so it creates this parabola. Does that make sense? Sort of? No?
Yeah, it does.
No? But see, the clock starts ticking here. Right here, time is 0. The minute the boulder starts falling, the clock starts ticking. So you got and the time is moving to the right. And so to graph it, this is not what it looks like in real life, but in graphing it, you're doing it based on time. So at 1 second, the height of the boulder is going to be over here, right? And at 2 seconds, the height of the boulder is going to be here. At 3 seconds here, and 4 seconds here at 0. So I mean, yes.
I thought a parabola was like where it goes like that.
It does. It does. The only thing is, sometimes the parabola is a part of a parabola. So look, we've got this right here. This is where it started, and now it's going to probably continue there. But there's no such thing as a negative time. Does that make sense? So I don't have to draw it. In real life, we have these parabolas, but in real life examples, oftentimes it's the positive answer that we're looking for, not the negative, in a real life situation. Does that make sense? Right? That was a great question. Okay, it makes sense, you guys? So, let's see. Do you want me to do another one, or do you feel like you've got it? Should I do one more?
Yeah, let's do one more.
One more.
No,
Okay.
that's one against like the whole class. Yeah, bring this thing.
All right, let's do number 5. Okay, a rescue plane.
Jewish Middle East.
With life-saving medicine and food is flying in a level direction meaning parallel to the earth, right? At a height of 5,000 feet. If it drops the bundles of medicine, right? Bundles of meds and food. How long will it take to hit ground? Okay, here we go. All right, so a rescue plane with life-saving bundles of medicine and food is flying in a level direction. Level means parallel to the earth, right? And at some point, at a height of 5,000 feet, it drops the bundles to the ground. Now, the bundles are moving at the speed of the plane. Do you agree with me? Right?
So when it drops, it's going to be going.
But is there initial vertical velocity? Are the bundles being thrown upwards first? No. They're just being dropped. It doesn't matter that they're moving in this direction. Does it, you see what I'm saying? It just matters that they're dropped and there's no initial vertical velocity. So my v, again, is 0, right? So really, all I'm doing with these is h is equal to negative 16 t squared plus s. Does that make sense? Because there's no v. There's no vertical velocity, right? Therefore, here we go. H, let's see what it says. How long will it take to hit the ground? Well, first of all, write my equation. H is equal to negative 16 t squared plus what?
5,000.
5,000. And then what do I have to make H?
16 t squared.
Well, what do I have to make?
You have
Yeah.
to add.
How long will it take for the height to be 0? You know, when it hits the ground. So it's going to be 0 is equal to negative 16 t squared plus 5,000. Now what do I do?
Add 16 to both sides.
Right, add 16 t squared. So that would give me 16 t squared is equal to 5,000. Now what would I do?
Divide by 16.
Divide by 16. Anybody have a calculator on them?
No.
Here. Do you have one? You rock. Okay, what's 5,000 divided by 16?
It's 312.5.
I thought you would have been able to do that in your head, Rowan. That's the problem.
What?
Can't you do that in your head?
No.
Me neither. What's the square root? Okay, square root both sides.
It'll just be like t.
So with that figure, hit the square root sign. So t is equal to 312.5 square root.
17.67. I was close. Okay, I said 106.5.
Okay, so it's plus or minus, right? But what's the real answer? It's going to be positive, right? So it takes 17.67 seconds. Takes 17.67 seconds. It's so easy, right? So easy. Because you understand the quadratic formula. You understand these different parts and where they go. Does that make sense? All right, so I'm going to end the lecture and I'm going to have you guys work on the homework. Does that work?
Okay.
Okay.